All right, my name is Avdi, and this talk is about failure, how to deal with it in Ruby. Let's start off with some definitions of terms. What do we mean by failure? One way of looking at failure is in terms of contracts. Every method has a contract. It could be explicit, could be implicit. Every method has a contract that says, you give me certain inputs, I give you certain outputs. And the guy that first espoused this idea of software as contracts was Bertrand Meyer. He created the Eiffel programming language. And this is actually kind of relevant to us as Rubyists because Ruby derives a lot of its exception handling system from Eiffel. Meyer defined failure as what happens when a method is unable to fulfill its contract. This could happen for a number of reasons. It could be a mistake in the usage of the method. Technically, this is a failure of the caller, but sometimes the method is responsible for reporting it. It could be a simple mistake in the code, a typo, using a string where we should have used a symbol. It could be an unexpected case. Maybe there were some insufficiently specified requirements. Or it could be the failure of some element completely external to the program that we have no control over. I want to start you off, now that we have some definitions, with a whirlwind tour of the Ruby exception system. It all starts with a raise or fail. Raise and fail are synonyms in Ruby. They do the exact same thing. Raise has become, I think, more popular lately than fail. But I was talking to Jim Weyrich when I was originally preparing this talk, and he introduced me to the convention that he uses, which I thought was kind of interesting. He says fail. He uses fail when he is indicating that something has failed, and he only uses raise when he is re-raising an exception that has been rescued. Kind of like this convention. I'm starting to use it more myself. Raise with no arguments is equivalent to raising a runtime exception, runtime error. Raise with a string is equivalent to raising runtime error with that string. Of course, we can also specify exactly which exception class we want to use. There's a third argument to raise, which will specify the backtrace. This is kind of useful for things like assertion methods, where we would like the backtrace to point back to the place where the assertion failed, rather than where assert was defined. In Ruby, raise is not a keyword. It's actually a method. It's just another method defined on kernel. It's some special functionality. And as you know, in Ruby, if something is a method, we can redefine it. So you can have some fun with this. For instance, here's a modification of raise, which simply makes every exception an instant death failure. So no exceptions for this program. I'm not sure I would recommend doing this, but you could do it. For a potentially more interesting redefinition of raise, you can take a look at the Hammertime gem. This was an attempt I made to implement a kind of small talk or Lisp style error console in Ruby, where instead of just raising the exception up the call stack, instead at the point of the raise, it pops up a prompt and asks you if you want to debug at that point, or if you want to drop into IRB, or if you want to just ignore it as if it never happened. What is raise doing inside anyway? Well, raise has basically 4 steps to it, if you look at its implementation. The first step is getting the exception object. The second step is setting the backtrace. The third step is setting the error info variable. And the fourth step then is throwing the exception up the call stack. The first step is setting or is getting the exception object. And when you look at the way raise is called, you might think it's implemented something like this. You might think, okay, so it gets a class and a message, so it's just calling class.new with that message. It's not actually what it does. It actually calls .exception on whatever you pass to it. What the heck is .exception? .exception, you can think of this as kind of a exception coercion, like you have 2s or 2a in Ruby if you want a string or an array. You have .exception when you want an exception. Now, by default, out of the box, Ruby only defines this on the exception class. So it's defined at the class level. At the class level, it's basically the same as saying .new. At the instance level, it's going to either return the same exception object it was called on, or it's going to generate a new exception object depending on how it's called. Just because Ruby only defines it on the exception object doesn't mean we can't define it in other places. Here's an example of defining a .exception method on an HTTP response. So this gives the HTTP response the ability to generate its own appropriate exception for whatever that response is. And then client code could then decide whether it wants to raise an exception. If it wants to raise an exception, you can just raise that response, and that's going to be automatically coerced into an exception. Step 2, setting the backtrace. Not much to say about that. Step 3 is setting the error info variable. This is a global variable in Ruby, or at least a thread global, you could call it, which always contains the value of the most recently raised exception. So if there is an exception being raised, then it's going to contain a reference to that exception. If there's no exception being raised, it's going to be nil. And you can see that in this code. Before the raise, it's nil. During the raise, it is set. And then once the exception has been handled by the rescue clause, it is once again nil. And what you can also see in this code is if you don't like the obscure $bang syntax for the error info variable, you can require English, and you can refer to it as error info. Step 4, finally, is throwing it up the call stack until it hits a rescue or an ensure or the top of the program. So we rescue exceptions using the rescue keyword. Rescue with no arguments. Rescue with no arguments catches any exception, right? A lot of you know this one. No, it does not. It rescues standard error, which leaves you with a fairly long list of exceptions that will not rescue by default. And this is something that often catches people that are new to Ruby by surprise. You can give a name to the exception that rescue catches. And in this case, it's equivalent to calling it with the class standard error. You can pass a class for it to rescue, or you can pass it a list of classes for it to rescue. Now, this syntax might look a little bit familiar. It's kind of similar to Ruby's case statement, and that's not a coincidence. The way Ruby matches exceptions is very similar to the way it matches objects in case statements, and we can use this knowledge. The way it's actually matching those exceptions is it's using the 3 equals operator the same way case does. So knowing this, we could actually define our own exception matcher objects that define their own 3 equals operators to match arbitrary aspects of the exception other than their class. Now, there's a kind of a gotcha here. Ruby somewhat arbitrarily requires that object passed to rescue to be a class or a module. It can't just be some instance of object. So we have to do a little bit of fancy coding to generate a dynamic module which has that 3 equals operator on it in order to satisfy Ruby's requirements. But once we've got that out of the way, we can do something like this. We can say, rescue errors with message matching socket. That'll rescue any exception with a message matching that, that regular expression. Ensure is where we put code that we want to always be executed even if an exception is raised. Good for cleanup. There's a kind of a weird edge case that Les Hill documented about ensure, which is that if you explicitly return inside an ensure block, it'll just throw the exception away as if it never happened. And this could be somewhat surprising. So my recommendation, just don't explicitly return inside an ensure block. Ruby is one of the few languages that provides a retry facility for exceptions. So here's a sort of classic example of using retry. We set a tries counter. We try something that might raise an exception. And the first few times that it fails, we just increment the tries counter and then use retry to throw execution back up to the beginning of the begin block. Finally, if the tries counter gets up to 3, we say, okay, we're giving up. We don't retry it again. What happens when we raise an exception while rescuing another exception? Depends on how we call raise. You can raise a completely separate exception, in which case the original exception will be just thrown away, never to be found again. I have found a few instances where the Rails code base does this. Please don't do this. It's really annoying when you're debugging back to the source of an exception that's been raised, and you realize it was raised while handling another exception, and you have no idea what that other exception was. An alternative to throwing it away is to use nested exceptions. Ruby doesn't have these out of the box, but they're very easy to implement. Nested exception is just an exception that contains a reference to the original exception that spawned it. And you can, in this very simple implementation of it, you can explicitly provide a reference to the original exception. But you can also just raise a new exception without providing that explicit reference to the original, and it'll just figure it out. It does that using that very handy error info variable that we saw earlier. If you re-raise you can re-raise the exception that you rescued, and this will simply raise the exact same object with no changes. You can re-raise the same object, the same exception, but with a new message, and this will actually use that .exception method to generate a new exception based on the old exception, except with your new message. This is really handy if, at a higher level, you have more information about the context that exception was raised in, and so you can add some useful contextual information to that error message, and then rethrow the exception back up. And finally, you can also alter the backtrace of the exception when you're re-raising it. If you call raise with no arguments whatsoever inside rescue, it's just going to re-raise the exception that's currently being handled. Let's have some more fun with overriding raise. So some languages disallow this concept of raising an exception while handling another one. And there's some good reasons for this. As we saw earlier, it can complicate debugging to have these secondary exceptions raised, and also sometimes it results in resources not being cleaned up. So we could, if we wanted to, we could do that in Ruby, and it's pretty straightforward. We just define a raise which checks the value of that error info variable and sees if there's currently an exception other than it sees if we're trying to raise a new exception without having handled the first one. So we're also providing this little helper method called error handled, and this is a way that we can explicitly tell the system, yes, this exception has been handled, and now I want to raise a new one. And what it's doing is it is setting that error, manually setting that error info variable back to nil. So when we use it, now if we include that into the global object, now we can, if we raise a second error while rescuing it first, it's just going to end the program. But if we explicitly call error handled and then raise a second error, it's fine. If an exception is never rescued, eventually Ruby is going to hit the top level of execution. Ruby is going to end the program. But it is not going to end the program until after it calls various on-exit handlers. I'm not going to go over the difference between trap and add-exit and end, but the point in this little code example is that all of them are executed. In the case of an uncaught exception, all of them are executed before the program exits. This is a useful piece of knowledge. If you've ever had a system where you wished you could add some crash logging to it, but for some reason it was a system that was really hard to wrap a global begin, rescue, end block around, like a web application server. Often it's not very clear where you would put that global begin, rescue, end. You can actually insert an exit handler, an at-exit handler, which will, at the exit of the program, use that error info variable to check to see if we're exiting because of an exception. And if so, it's going to log some information about that exception to a log file before ending the program. In this case, we're capturing some information about the exception. And we're also capturing all the versions of all the gems that were loaded when the exception occurred. I'm sure you can probably think of all sorts of other useful stuff to put in a log like this. Once we rescue an exception, we need to figure out what to do with it. We need to figure out how to handle it. There are various ways to handle it. One popular method is simply to return some kind of error value, which in Ruby is often nil. A related approach, which is sometimes more useful, is to return some kind of benign object, which implements the interface of what that method would have been returning, but with some sort of known benign value that isn't what we wanted, but isn't going to hurt anything. It's not going to cause something else to crash the way a nil might. We may want to report that exception to some sort of external service. We might want to log it to a file. We might want to report it to a third-party service like Opto or Exceptional. But be careful when you're doing this. Be careful that you don't make the problem worse. I'm going to tell you a little story about this. I worked for a company once where we had a cloud of workers and other processes, manager processes, and other processes, and they were all working together and communicating with queues. The workers would work through jobs, and they would execute the job and then pull another one off the queue. And sometimes the jobs would fail. And we had a simple error reporter for the failed jobs. It would basically mail us, we would use our Gmail account to mail the dev team some information about the exception, and then the worker would move on to the next job. This was fine, it worked well, until we rolled out a release that drastically increased the number of failed jobs. And we had so many failed jobs, as a matter of fact, that all of those error reporting messages caused Gmail to throttle our Gmail account. Now, the way the error reporting code saw this was in the form of SMTP exceptions. That code had never been written to handle SMTP exceptions. So now the error reporter was failing, and that caused the whole worker to crash. So now we had workers crashing left and right. But that's not the end of it, because we were also using that same Gmail account for unrelated services that were also reporting things to us. And so they would try to report their thing and get an SMTP exception because our account was throttled. And so we had unrelated services crashing, all because of this one not so robust error reporter. So be careful with your error reporting that you don't make things worse. One way to address this is with a pattern called the circuit breaker. This was introduced to me anyway, by Michael Nygaard in his wonderful book, Release It. I'm not going to go over the details of that pattern right now, but I definitely suggest checking this out if you've ever seen issues like this. All right, so we've talked about raising exceptions. We've talked about rescuing them and handling them. Now I want to spend some time talking about your overall error handling strategy and how to structure it. The perennial problem, the perennial question in dealing with exceptions is, what warrants an exception? When should I raise an exception and when should I not? I've come up with 5 questions that you can ask yourself before raising an exception to sort of make that decision. Question 1, possibly the most important question. Is the situation truly unexpected? Is it exceptional? Exceptions are for exceptional circumstances. They are not for normal straight line expected things, things that you expect the code to handle. And one example of something that really isn't exceptional is bad user input. Any system that interacts with humans at keyboards cannot treat invalid input as an exceptional case because you're going to get it. And I used to think that the active record save method was clearly wrong because it would not raise an exception by default. It would not raise an exception when you saved invalid data. But I've realized since then that that is expected. That's part of the life cycle of a web application is bad data coming back from the user. And so it really does make sense that that's not treated by default as an exception in active record. Sometimes you want exceptional behavior. You want to be able to break out of arbitrary, multiple, deep levels of execution. But it's not an exceptional case, and it's an expected case. And in some languages, you just have to abuse exceptions if you want to do this. Ruby, thankfully, gives us an alternative. Ruby has something called throw and catch, which is explicitly intended for this situation, where you can basically label a block of code as a place that execution can be thrown back to. And there's an excellent example of this in Sinatra and Rack, where in Sinatra you can say last modified, and this is going to interact with the browser to check to see if the browser already has the most recent version of a resource. And if it does, the implementation is going to throw halt. And then Rack, deep in Rack, it's going to catch that halt throw, and it's just going to end the request right there. It's going to finish the request, and it's done. And possibly avoiding expensive processing later on in that. Later on in that action. So nothing after the last modified gets executed because the execution is thrown out of there. So throw and catch are great. Use them if you have a situation that seems like you want to throw exception out, but you don't. But it's not truly exceptional, or it's throw execution out, I should say. Question number 2. Am I prepared to end the program over this? Any exception, if not rescued, can potentially end the program, or in a web application server can at least potentially end the request. Sometimes just looking at the question from this perspective, rather than the perspective of what the exception is, will sort of put it in a different light. You'll think, this is actually not that bad a case. This is not part of the primary purpose of this request or action or command, and maybe it's okay to just return some kind of benign value and continue on, or maybe note the failure and continue on. Question number 3, can I punt the decision to someone else? This problem of what constitutes an exceptional situation persistently vexes us. Is an end of file marker a failure? Is a missing hash key a failure? What about a 404 in HTTP? And the answer to all of these is, it depends. It depends on the context, it depends on the situation. But when you raise an exception, you force the issue. You say, I know that this is an exceptional circumstance. This is a failure. What I like to do anytime that there's some sort of ambiguity in a program is see if I can punt the decision somewhere else. See if I can especially punt it higher up, punt it to the caller. And and Ruby provides us some great ways of doing this. You can see an example of this in Ruby standard libraries, most of the standard collection classes implement a fetch method, which will fetch a value at a given key. But you can supply a block to it, which will specify what to do if the key is not found. So for some keys, for optional keys, you might just substitute a default value. For required keys, you might raise an exception there. And this is what I think of as a caller-defined fallback strategy. And it allows the caller to make that call of what is exceptional, what isn't. You can see this in various forms. The detect method, in the detect method, the block was already taken. And so the Ruby library instead uses an argument to provide that fallback action. And it's very easy to do this in your own code, to provide some way for the caller to you can do something like this, where you can provide a block to your method, and the caller then decides how to handle when the request doesn't work. Question number 4. Am I throwing away valuable diagnostics by raising an exception? So you have some process that takes 15 minutes to complete, and it's collecting output or it's collecting data. It has all this context, and then right at the end, some trivial thing raises an exception, throws all that stuff away. Probably not a good idea. Probably not what you want. This is a case where you might decide not to raise an exception. You might decide to maybe collect some error flags along the way, or collect a log along the way, and try to avoid raising exceptions at all costs. On the flip side, what about cases where not raising an exception would cause a less informative exception to be raised later? So if you have some bad input, if you have a nil where you didn't expect it, and that's going to somewhere down in the code base cause an obscure no method error to come bubbling out, that's a case where it makes sense to fail early rather than force the user to debug that no method error. Exception handling code is not part of the straight line business logic of your program, and it's often very distracting to have it interrupting your code here and there. And so I like to, as much as possible, isolate my exception handling code to sort of its own methods. And towards this end, I actually think of the begin keyword in Ruby as kind of a code smell. I don't know if you've ever dealt with code that had deeply nested begin, rescue, end blocks like this, where you're like 3 levels deep in them. And I've run across a few of these, and they were always buggy. They were always source of bugs, very hard to understand, and often they were doing the wrong thing anyway. Ruby gives us this wonderful idiom where if you only have one level of exception handling in your method, you can do away with the begin completely, and you can just basically have a method in 2 parts delineated by a rescue statement. So you have the business logic up here, then you have rescue, and then you have you have failure handling below that, and then the end. And I like to factor my code so that this is all I'm using, and there are no begins. And I find that this really leads to a cleaner, more maintainable code base. One way you can move towards that is by using something I call a contingency method, where you basically note that if you have a code base where there are all these instances where you have some file operation that is then followed, that is surrounded by begin, rescue, end, where you handle the I/O error that might come out of that file operation. You can extract that out to a contingency method whose only job is to run its block and then implement a failure handling policy. And so you have that failure handling policy for I/O errors in one place, and then everywhere in the code that needs it, you just surround it with I/O error handling, and you factored that out. You're not using a begin anymore. Here's a pop quiz for you. What parts of this code can raise an exception? Anything? Any ideas?
The first 2.
The first 2?
All of it.
I heard that. All of it. It's a trick question. The true answer is all of it. Ruby is a language where certain exceptions can be raised at any time. So there are exceptions like no memory error, or if somebody hits Control-C, that interrupt exception, that could happen anywhere. There is no limit. So Ruby doesn't give us any promises about this stuff. And this is a little scary. And it causes us to think about, how will this method behave in the presence of an exception? And there's this old concept called exception safety, which describes the level of or how a method will behave in the presence of an exception. And there are traditionally 3 levels of exception safety. There's the weak guarantee, which says if an exception is raised, the object will be left in a consistent state. It might not be the same state that it started in, but at least it'll be consistent. It won't be just broken. There's the strong guarantee, which says if an exception is raised, the object will be rolled back to its state before the method was called. And that's kind of a transactional behavior. And then finally, there's the no-throw guarantee, which promises that no exceptions will be raised at all. This stuff, it's useful to reflect on your methods in terms of these levels of exception safety, and think about what level does this method guarantee, what level should it guarantee. You can't do this with all of your code, but there are certain critical methods like that exception reporting routine that should have handled SMTP exceptions, where you want to think about this. And there are some automated methods for validating these statements. I don't have time to go over them right now, but there are some ways that you can actually test and verify that code meets one of these guarantees. Here's an anti-pattern for you. Handling overbroad exception, or putting overbroad exception specifications in rescues. Every time I run into one of these, it's usually because I'm trying to figure out why the code doesn't fail, but it doesn't work either. And I discover that's because some exception is being eaten by an overbroad rescue. Sometimes you can't avoid putting something like exception in here just because some piece of software throws or raises a really overbroad exception type. But if nothing else, try to maybe match on something that's unique about that exception. Match on the message is one way you can do it. A common annoyance that I hear from people when they're talking about what they don't like about exceptions, or what they don't like about dealing with exceptions with certain libraries, is that some libraries will raise all kinds of different exceptions. And so you think you've handled everything that can come out of that library, and then you get a new one. Ruby's HTTP library is a common offender here. And because it can throw, it's got HTTP exceptions, but then you've got like I/O errors, and you've got like system call errors. So one nice thing that you can do for your callers is you can tag all of the exceptions that bubble out of your library with something I call a module tag, which is basically a module that exists just to tag objects as being part of a certain group. And so here's an example of doing that. We rescue any exception, but then all we do is we tag it with our tag module and then re-raise it. What that gives client code the ability to do is it has the confidence that it can just rescue that one tag, and it'll be rescuing any exception that comes out of that library. Another common question when thinking about an app's error handling strategy, question that I've pondered at pretty much every project that I've started, is how do I structure my exception hierarchy? And there are a lot of answers to this. There are a lot of possible answers. You could base it on, you could have different exceptions by module of code. Different subsystems have different exceptions. You could have different exceptions based on sort of the strata of the code, low-level exceptions and high-level exceptions. You can even do exceptions based on severity, if you wanted to, and all these have different merits. One way I like to look at it is to look at it in terms of how the exceptions are going to be presented, how they're going to be handled. Because really the biggest reason that we raise different kinds of exceptions at all is because we expect to handle them in different ways. And there are other reasons, but the big thing is that we want to be able to switch on the exception type so that we can handle them different ways. And so what if we worked backwards? What if we looked at the different ways in which exceptions are handled or presented and worked backward from that? Well, if you look at a typical web application, you see three major categories of how an exception is presented. So you see, the first one is the user error. It says, you have done something wrong, and only you can fix it. You need to change something that you did and try again. And then you have the logic error. Logic error says, there is something wrong in our code. You can't do anything about it. The only thing you can do is report it, or hopefully that we've reported it ourselves, and wait for a fix. And finally, you have the transient error, which says, you didn't do anything wrong. And there's nothing broken on our end, but we're just over capacity right now, or something is undergoing maintenance right now. And so what you can do as a user is come back later, and everything should be fine. So these three messages, in my experience, these are like 80 or 90% of the differentiations in how exceptions are presented and how they're handled. So working backwards from that, we get three main exception classes: user error, logic error, and transient error. And I find that these pretty much give me the categories that I need for most programs as far as switching on on a user error. I want to represent the prompt to the user with some sort of message about what they did wrong. Logic error, I want to report that there's a bug in the program. And transient error, I might want to do some kind of retry logic. I thought about trying to put together a slide that would sum up everything you've learned, but I don't know, there's a lot of information, I couldn't do it, so sorry. But hopefully you have taken something useful from some part of that. If you want tons more on the topic, I did write a book on exceptions in Ruby, and there's a discount code you can use. Sorry, I had to put the obligatory plug in there. And there's some contact information, and that's it. Are there any questions? I think I've got a little bit of time.
Are there some libraries that use that exception tagging?
The question is, are there some libraries that use that exception tagging? There is one now. Mislav, I hope I'm not mispronouncing his name, was talking to me about some exception handling in the will paginate plugin as he was updating that for version 3. And I said something about that pattern. I think you went with that.
We had some internal office discussion about whether we should try and put exceptions specific to some stuff we were doing inside of a module, like namespace our exceptions or not. Do you have any feelings about whether it's okay to put them in the global space or whether they should be kept in a module?
So the question is about namespacing exceptions, putting them inside a module, or just putting them in the global namespace. Honestly, I don't have really strong feelings about it. I mean, if you're developing a library, I generally think that everything in a library should at least be inside the top level library module. But beyond that, I don't know.
When we were talking about using a blank rescue and it only catches standard error, and you had a list of things that it doesn't catch, is there a way to, or is maybe in your book that explicitly listed somewhere what all is missed when you just do a blank rescue?
Yeah. So the question is I said something about rescue not catching certain blank rescue not catching certain exceptions, and is there a list somewhere of all the, or a way to list all the exceptions that it's not going to catch? There is. I think, do I have a link to the show notes? I took the show notes link down. Search for exceptional Ruby. I've got like a talk notes page that has a bunch of references on it. there's a blog post out there that's got a nice snippet. I did include this in the book as well, but I think it's Nick Seeger has a snippet of code that will basically use Ruby to introspect on the entire exception hierarchy and list it out for you. And then you can see.
All right, thank you.
Are there any libraries that you've seen that are just spot on? They have like great exception handling, or it's a great example?
So the question is, are there any libraries that have that are really good examples of great exception handling? I wish I had an answer to this. I need, and it's not because all the libraries out there suck. It's just that I don't spend enough time code reading, honestly, and I should spend more. I don't have somewhere to point you off the top of my head. I'm sorry.
I did C++ for a few years, and there we had kind of these weird practices where when you couldn't get memory to allocate a new object, you could usually you just failed right away, but you could try and wait a little bit to see if it came up. In Ruby, if you get a no memory error, is it even worth trying to wait and see if you can get memory? You can just kind of quit that.
So the question is, in Ruby, if you get a no memory error, is it worth trying to wait around to see if you can get some more memory or not? I'm not really sure the answer to that. I mean, I've seen techniques in some languages where you sort of hang on to a pool of memory, and then if you get the no memory error, you release that pool and do some error reporting and then die. I'm not sure how useful that would be in Ruby. Honestly, that's a little bit beyond what I've researched.
Do you have any practical ideas for the passing a block of possible ways of handling an exception from the caller to the colleague?
Practical ideas on passing a block for handling the exception from caller to colleague. When you say practical ideas, I mean, what do you...
things you've done with it, or?
I'm trying to think of a specific example. I often just like sort of permeate the code with it, honestly. You know, anywhere that you're doing something particularly that might be like dependent on an external service, you know, web requests and stuff like that, is often a good place for code like that, where you let the caller decide whether that's a problem or not. Anything else?
How do you verify that the object got rolled back on an exception?
How do you verify that the object?
You said there was some automated way of.
How do you verify? Yeah. So there's a technique. The question is, how do you verify stuff like the exception safety guarantees, basically? And there's an exception testing technique which I didn't have time to go into in this talk. I hate to plug the book again, but I did put.
It's in the book.
Oh, you know what? Actually, the code that I did for it is out there. Once again, sorry, I didn't put the talk notes URL on there, but you can just Google exceptional Ruby Avdi.org or something like that, and there's a talk notes page. There's a link to my proof of concept and implementation of an exception safety verifier. So take a look at that. All right.
Have you thought about like instances like the pros and cons of using like a continuation, where you would use a throw catch?
So pros and cons of using a continuation versus throw catch. Well, definitely done code where I threw a continuation. But I don't know. You know, I haven't done that recently. There were some memory leak issues with continuations for a while. I'm not sure how it is in 1.9. You can do cool. I will say this: you can do really cool stuff with that. But that's like a whole, I don't know, 15-minute conversation that we can have in the hall. And I think out of time. Okay. All right, that's it. Thank you very much for coming.